word heat it is built in, or you can say gadget heat. Gadget heat or inbuilt heat. When ice is heated, it melts at 0 degree Celsius and converted into water at this constant temperature. It's a constant temperature of water. When you apply the heat to the ice, it's converted in 0 degrees Celsius. This constant temperature at which the ice converts into water is called the melting point of ice. That is the definition of melting point of ice. Heat energy is utilized for weakening the bonds between the atom or molecules in a solid and transform into a liquid phase. The heat energy absorbed at constant temperature during transformation of solid into liquid is called the latent heat of fusion. This word, the latent heat of fusion, it is the bonding between atom and molecule of the solid which transferred into a liquid phase. When the solids, the example as you know, it is given for the ice. Ice is the form of solid, and when you apply the heat to this, so is break the bonds of that molecule and it convert in liquid phase. So at that time the constant temperature absorbed solid into liquid. So it is known as the latent heat of fusion. Amount of heat energy absorbed at constant temperature by unit mass of solid to convert into liquid phase is called the specific latent heat of fusion. It is clear?
Yes, sir.
Yes, sir.
It is clear to all of you, no?
Yes, sir.
Yes, sir.
Now heat energy absorbed by water at the temperature and used to break the bonds between molecule of the liquid and convert liquid into gaseous state. Thus, during transformation from liquid phase to gas phase and heat energy is absorbed by the liquid, but its temperature does not change. The constant temperature at which the liquid transforms into gaseous state is called the boiling point of the liquid. It is known as the boiling point of that liquid. As the liquid, you apply the heat and it start converting into a gaseous state. So that time the temperature does not change. That heat energy absorbed by the liquid, but the temperature does not change and remain a constant to change in the liquid to gaseous form. So it is known as the boiling point of that liquid. Then the amount of heat energy absorbed at a constant temperature by unit mass of liquid to convert into gaseous phase is called the specific latent heat of vaporization, because it is started constant temperature by unit of the mass of liquid convert into gaseous phase. As you get the in steam, so that time it convert into a gaseous phase, so it is known as the specific latent heat of that vaporization. It is clear?
Yes, sir.
Now the next part is regelation, the phenomena in which the ice converts to liquid due to applied pressure, then reconvert to ice once the pressure is removed, is called the regelation. Regelation, it means when ice convert in liquid by pressure, and when again it reconvert to ice once the pressure is removed, is called the regelation. The melting point of ice becomes lower than ice than 0 degree Celsius due to pressure. This means to 0 degrees Celsius, the ice gets converted into water. As soon as the pressure is removed, the melting point is restored to 0 degrees Celsius and water gets converted into ice again. Anomalous behavior of water. When a liquid is heated up to a certain temperature, it expands, and when cooled, it contracts. Where, however, shows a special and exponential behavior if we heat water from 0 degrees Celsius to 4 degrees Celsius, it contracts instead of expanding. At 4 degrees Celsius, its volume is minimum. If the water is heated further, it expands and its volume increases. The behavior of water between the temperature from 0 degrees Celsius to 4 degrees Celsius is called the anomalous behavior of water. When you apply to heat to water, so it expands, and when it cools, it contracts. Water, however, show a special and exponential behavior if we heat water from 0 degrees Celsius to 4 degrees Celsius. For the other liquid, it is important to be expand, and when it is cooled, it will be contract. But the water, it is the different behavior. When it is heated, it is contract, and when it is cooled, it expands from 0 degrees Celsius to 4 degrees Celsius. So this behavior of the water is called the anomalous behavior of water. This study of the anomalous behavior of water be using Hope's apparatus. It's the
Sir,
most important part of the chapter. Yeah, hello.
sir, what is the similar term for word anomalous?
Similar term for the anomalous we can use like the different we can say no.
Okay, sir.
It's a different behavior means is the expansional behavior you can say. It is like the suppose someone has we can say it is intelligent but
Sir,
for
can we
someone
say it unusual?
unusual correct.
Okay, sir.
That is the diagram of the Hope apparatus. This year to remember the naming because sometime it asked in a paper to draw the diagram or if it asks for the 5 marks question so you have to draw the diagram to show the working of the Hope apparatus. Hope apparatus consists of a long cylindrical jar with two openings on the side. Cylindrical jar with the two opening on the side. Here you can see in a jar, then one near the top and the other near the bottom to fit a thermometer in each of these openings. Here you can see the two thermometers which is fit in the top of the and in the bottom. A metallic cylindrical air tight through with an outlet is also fitted onto the jar on its central portion. Here you can see this one. These two thermometers are fitted airtight in the two openings of the cylindrical jar. The thermometer near the bottom of the jar is T1, temperature 1, and the one near to the top of the jar is T2. Now the cylindrical jar is fitted with the water and the cylindrical through at the central portion of the jar is filled with a freezing mixture of ice and common salt. Cylindrical of the central portion of the jar is filled with the freezing mixture with ice and common salt. Here you can see this one the ice freezing mixture, and when it is melt you can see here in the beaker collected the water. So and apply the heat to this, so it's 4 degrees 7 Celsius to convert it in 0 degrees Celsius. So it started expanding over there as, but the behavior of the water is different from the other object. So it started contracted at 4 degrees Celsius and it reaches up to 0 degrees Celsius. So it again started to expand. It is clear? Initially both the thermometer shows the same reading, says 12 degrees Celsius. It is taken as an example. As though filled with the freezing mixture, the water in the central portion of the jar loses heat energy and gets cooled. Its volume decreases and density increases. As a result, the denser layer of the water in a central portion moves downwards and displacing the lighter layer of water there towards the central portion. This forms a convection of water. Due to this convection, the thermometer T1 near the bottom shows a rapid fall in temperature till reduces 4 degrees Celsius. At 4 degrees Celsius, the density of water in this part of the jar is maximum. Thus, the dense water remain dense water remain in the lower portion and temperature recorded by thermometer T2 and remain almost unchanged. Now the water in the central portion of the jar cools to below 4 degrees Celsius. Due to anomalous expansion of water, it begins to expand as the volume of the water increases. Its density decreases. As a result, it moves upward. Thus, the thermometer T2 shows a rapid fall in temperature. However, the temperature of the water in the lower portion of cylinder remains at 4 degrees Celsius. The temperature of water in the upper portion of the jars continue to decrease gradually below 4 degrees Celsius because of the behavior of water. As the temperature of water decreases from 4 degrees Celsius to 0 degrees Celsius, it expands and its density decreases. Hence, the cold water rises to the surface and form a thin layer of ice. The ice floating on the surface of water indicate the density of the ice is less than the density of water at 4 degree Celsius. Temperature in thermometer T1 is remain 4 degrees Celsius while that in thermometer 2 falls to 0 degrees Celsius. This is due to the anomalous behavior of water. If you plot a graph for the variation of the temperature recorded by thermometer T1 with the time, it will be shown here. Similarly, the graph of temperature recorded by the thermometer T2 time will be as shown. That is, you can see in the graph. I think it is given in the textbook. So it is clear. Yes, it is clear. Is clear to all of you?
Yes, sir.
What about the remaining? All are sleeping or what?
Yes, sir.
No.
A good story is going on, no? Now, dew point and humidity. What the dew point? What the mean of this word dew point? Anyone? Yes? Ever you heard this word dew point?
A temperature where air can hold no more water.
That you can read from there. It's very simple to be read, no? Yes, Niharika. Dew point means, as you heard this word, dew point. Dew means in this winter season. Mostly you heard this word in winter season. Dew means in Hindi you can say the oats, or you can see in the night time it is all are wetted. Whenever the object is outside of the home, you can see it is wetted. It is a dew point. So why it is happen in scientific word, we can say, suppose unsaturated air at a certain temperature is taken and its temperature is decreases. A temperature is reached at which the air becomes saturated with vapor. This temperature is called the dew point temperature. Temperature is reached at which the air becomes saturated with vapor. This temperature is called dew point. Its temperature is decreases because after the rainy season, or you can say summer, the temperature started decreasing. When the temperatures are decreases, so it reach at which the air becomes saturated with vapors. So it is called the dew point of the temperature. The vapor content in the air is measured using a physical quantity called absolute humidity. Air content in the air is measured using a physical quantity is called absolute humidity. The mass of the vapor present in a unit volume of air is called absolute humidity. Generally, absolute humidity is measured in kg per meter cube. Is measured in kg per meter cube. The ratio of the actual mass of the vapor contained in the air for a given volume and temperature to the required to make the air saturated with vapor at the temperature is called the relative humidity. For that, we use a formula to measure the relative humidity. It is given in your textbook. This one. The relative humidity, actual mass of water vapor contained in the air in given volume upon mass of the vapor needed to make the air saturated in that volume multiply with 100. So most of we use this formula to calculate the percentage of relative humidity. The relative humidity at the dew point is 100 degrees Celsius. If the 100% is not degrees Celsius, 100%. If the relative humidity is more than 60%, so we feel that the air is humid. If the relative humidity is less than 60%, we feel that the air is dry. In winter season, mostly the relative humidity is less than 60%, and in summer, it is usually more than 60%. It's clear to all of you?
Yes, sir.
Yes, sir.
Now, unit of heat. What the unit of the heat? The unit of the heats are joule in SI unit. In SI unit, we use the unit of the heat is joule, and in calories in CGS unit. Cal, it is calories, it is in CGS unit. The amount of heat necessary to raise temperature of 1 gram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 calories heat. Similarly, the amount of heat necessary to raise the temperature of 1 kg of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 kilocalorie heat. And it is clear that the 1 kilocalories is equals to 1000 calories. And mostly we use as the calories it is given in your textbook the for 1 calories we use as 4.18 joule. Whenever you have to solve the sums of this, so for using a calories, so you have to convert the calories in joule and you have to use the value is 4.18 joule. It is clear?
Yes, sir.
Now, specific heat capacity. The amount of heat energy required to raise the temperature of a unit mass of an object by 1 degree Celsius is called the specific heat of that object. Amount of heat energy which is required to raise the temperature of the unit mass of an object by 1 degree Celsius is called the specific heat of that object. The specific heat is denoted by letter C. The SI unit of the specific heat is joules per degree Celsius kg, and in CGS unit is calorie per gram degree Celsius. That's the unit of specific heat. That's the difference of heat and specific heat. In the same way, it is specific heat of an object is C, the mass of that object is m, and the temperature of the object is decreased by a delta. Delta is the difference of heat. For difference of the heat, we use this sign delta. Okay, delta T degree Celsius. Then the heat lost by the object will be a mass into specific heat into difference of temperature, m into C into delta T. It is clear?
Yes, sir.
Yes, sir.
Now the next part, heat exchange. If heat is exchanged between a hot and cold object, the temperature of the cold object goes on increasing due to gain of energy, and the temperature of the hot object goes on decreasing due to loss of energy. Heat energy lost by the hot object equals to heat energy gained by the cold object. This is called the principle of heat exchange. It is simple word. It is given that exchange between hot and cold object. Suppose I given one slab to Prathamesh, correct? So he start doing a work. So what happened over there? His energy is gained. Correct? It is clear?
Yes, sir.
Yes, sir.
All are there now? Anyone left?
Sir.
Now, last part of the chapter, measurement of specific heat. That is mixing method and calorimeter. Calorimeter we have to use to measurement of the specific heat. The specific heat of an object can be measured using a mixing method. For this, the calorimeter is used. Heat lost by solid object is equals to heat gained by water in calorimeter plus heat gained by the calorimeter. Heat lost by the solid object, that is Q. The mass of the solid object multiplied its specific heat, and multiply with the decrease in its temperature. Heat gained by the water, that is Q1, mass of the water multiply with specific heat into increase in its temperature. Heat gained by the calorimeter, that is Q2, mass of the calorimeter multiply with its specific heat and increase in its temperature. Now heat lost by hot object is equals to heat gained by calorimeter and plus heat gained by water. That is the main formula. Q equals to Q2 plus Q1. So all about chapter number 5. So here we completed our chapter